This video is a supplement to the Theory of Everything video. If you haven't watched the main video yet, please do so first. Without it, I don't think you'll understand anything from this point on. Now, let's quickly review the key points. Establishing the theory of everything required a new kind of mechanics. That is interatomic mechanics. There are only two principles. 1. It operates at the atomic level. 2. If something changes direction, it loses speed. That's all. In this video, I'd like to dive a bit deeper into this mechanics. The mechanics between atoms can be understood through the increase of entropy. The increase of entropy refers to the uniformization of the velocity information that each molecule possesses. This phenomenon, occurring within atoms and molecules, is what we call atomic mechanics. This formula represents the laws of motion for a single atom, but it can also be applied in this case. Now, let's simulate the collision of two spheres made of the same material, with the same density but different masses. When they collide, the velocity difference is transferred. This difference, following the law of action and reaction, moves back and forth between the spheres. The difference between atomic mechanics and Newtonian mechanics lies in the fact that forces are not transmitted instantaneously. The information gradually updates from the point of collision, and once the uniformization of information is complete, the spheres separate. In other words, as long as they are in contact, they continue exchanging information. Therefore, the small red sphere completes its uniformization first and moves away from the blue sphere. At this point, the blue sphere has only partially reached uniformization, so the process will continue within it. Finally, the information that was exchanged back and forth becomes divided into two, accelerating each sphere accordingly. The simulation assumes the same material, the same density, and the same shape as conditions. Next, let's talk about orbital calculations. In Newtonian mechanics, the Earth orbits the Sun due to the balance of three forces. In these calculations, the Sun is assumed to be stationary. In interatomic mechanics, however, the input angle of gravity relative to the direction of motion becomes important, allowing us to represent the Earth orbiting a moving Sun. We only need to introduce time variations and spatial density into these equations. By the way, when the direction of motion and the input angle of gravity are at right angles, and acceleration and deceleration are in balance, we call the state point x. If there are 2 points x along the orbit, orbital motion can occur. The closer the points x are to each other, the larger the orbital path becomes. However, achieving orbital motion requires one more element. This element is the same mechanism as the tides, which I explained in another video. It involves acceleration and deceleration caused by changes in the mass of matter. All matter is formed by particles wrapping around space, and the atomic nucleus changes its mass by either releasing or wrapping space, depending on the surrounding spatial density. Although we won't go into detail here, matter holds two types of velocity information. As these two pieces of information exchange, the matter undergoes acceleration and deceleration. Moreover, when gravity interacts with this exchange of information, as shown in the animation, acceleration slightly surpasses deceleration. Simply put, when matter moves through spaces with different densities, it accelerates. The Earth's orbital motion occurs precisely under these conditions. The greater the difference in spatial density, the larger the difference between acceleration and deceleration. This principle is what swing-by, gravity assist maneuvers take advantage of. Neither centrifugal force nor inertia plays a role in this process. This mass change accompanied by gravity also occurs in our daily surroundings. A prime example is a rotating object, known for the gyroscopic effect. When a difference in spatial density arises along the path of rotation, acceleration exceeds deceleration, just as it does in orbital motion. Therefore, when the spinning top tilts, it accelerates and returns to its original position. The gyroscopic effect has nothing to do with the law of conservation of angular momentum. In fact, there is no such thing as the law of conservation of angular momentum in this universe. According to the principles of interatomic mechanics, if something changes direction, it loses speed. In a rotational motion, all atoms changes direction. So rotation will eventually stop. But the Earth continues to spin, and that is due to gravity. Just as Earth revolves around the Sun because of gravity, the Earth's surface moves through space under the influence of gravity. The same applies to people standing on the surface of the Earth. All of this can be understood using the same equations. It's a very simple concept, and this applies to all the stars orbiting the galaxy. So, we do not need dark matter. On the other hand, when discussing the law of conservation of angular momentum, figure skating is often used as an example. That is speed moving through the body. The increase in entropy of information, the phenomenon repeatedly mentioned in the theory of everything. But, this leads to a contradiction. In this case, there is a difference in speed between the skater's center of mass and their fingertips. According to the increase in entropy, such speed differences within matter should equalize. So, what would happen if they did? This is what would happen. The skater's arms would tear off and fly away. If such a thing were to occur, it would result in a perpetual motion machine. This is why information uniformization does not occur within rotating objects. And instead, the system tries to maintain a balance between acceleration and deceleration. It is reasonable to assume that the Earth's rotation is also in this balanced state. However, there is an exception. It applies to cases with a rotational axis, such as the aforementioned spinning top or wheel. The speed is not used for rotation. Instead, it flows through the axis and is demonstrated in this video. On the other hand, if the axis is not in contact with any material, the result will be a different phenomenon, as shown here. All of these phenomena can be explained by mass changes and the uniformization of information. In Newtonian mechanics, individual phenomena are understood separately, without being unified. But, interatomic mechanics makes this unification possible, ultimately leading to the theory of everything. There are still some phenomena that remain to be fully explained, but it can be confidently said that this theory is superior to Newtonian mechanics. If this topic interests you, please share this video and discuss it with people around you. Lastly, don't forget to like and subscribe to the channel.